Good morning friends. Today I am going to discuss a topic on support vector machine. First of all, I have divided my topic into three categories. The first category is the introductory part, in which I would be discussing what is the topic, let us say support vector machines, and what are its features, why we need support vector machine algorithm. And after it, in the body part, I would be discussing what are the challenges and their solutions regarding the topic. And the last part is the conclusion part, in which I would be discussing my opinion regarding this topic. So without any wastage of time, let us get started. What is support vector machine? Support vector machine is a machine learning algorithm. It is a supervised learning algorithm that is used in classification and regression tasks. It is used to perform the regression as well as the classification tasks. It involves finding the hyperplane while separating the data points, that is support vectors, by maximizing the margin between them. So talking about why we need support vector machine algorithm. First of that, main reason is that it is highly it's very effective in high dimensional spaces. Second thing is that it is versatile. It is versatile because it uses kernel methods to separate the non-linear separable data points. Third thing is that it is very robust against overfitting. And the fifth one is that it is used in image classification, text mining, etc. Now, talking about the features of support vector machines. The first feature is that it uses the maximizing the margin feature. What does it mean? Support vector machines separates, in order to find the hyperplane, by separating the data points, it maximizes the margin between them. So this is the feature that is very crucial. Second feature in support vector machines is that it uses kernel methods. That is, it uses kernel methods which makes it more robust, and especially in finding the hyperplane by separating the non-linear data points for generalization purposes. Third feature is that it supports vectors. That means the subsets of support vectors are very effective in making the decision boundaries. So last feature is that it is used to solve the problems of black boxes. I would be discussing in the challenges and solutions. Now let us talk about what are the challenges and their solutions of support vector machine algorithm. The first main challenge that comes in support vector machine is that it is very expensive. The computational cost is very expensive. Why? Because in order to perform the high operations by using the support vector machine, it becomes very costly. So how to overcome this challenge? We can overcome this challenge using the stochastic gradient descent or other approximation techniques like minimal gradient or some other approximation techniques. And the second challenge that comes in support vector machine is the challenge of that it is very sensitive, that it is very sensitive to noise. So for that we can use soft margin techniques to overcome this. Third thing is that the third challenge of support vector machine is that it shows poor performance on imbalanced data. So for that we can use class weighting is a technique that we can use to overcome this problem. Okay, and another challenge that comes in support vector machine is the challenge of choosing the parameters. Yes, for that we can use the gradient search or we can use the other searching techniques. The last challenge, but not the least, in support vector machine is the challenge of black box nature. So as I recently discussed what is black box in the previous video. So black box is a phenomena in which some models, especially in deep learning, they act as black boxes. So what is black box? Black box is basically when the AI model makes decisions and it's hard for humans to understand that decision made by the AI. For that we use explainable AIs, but here with the support vector machines, we can use here some algorithms. We can use algorithms like linear support vector machines to overcome this challenge. So in conclusion part, I would like to say that support vector machine is not just a algorithm, but it is a more versatile and powerful, robust algorithm, and with it is having its challenges of that it is very sensitive to noise. It has a high computational cost. That means it is very expensive. But using these techniques, approximation techniques like gradient, stochastic gradient descent, or gradient search, other searching techniques. Yeah, we can use the linear or kernel methods to overcome these challenges. SVM becomes a very powerful and robust tool. Thank you so much for watching this video. Have a nice day.